linear equation in one variable. The mathematical statement in the form ax plus b, where a is never equals to 0 and a and b are constants, is a linear function. If ax plus b contains equal to sign, this sign, then the function becomes linear equation of one unknown, which is also known as one variable. In that regard, the equation becomes ax plus b equals to c. So this is a linear equation. Now a, b, and c become constants, and x is the only unknown variable which will be searched for. Let us try some common example with this. So we have a relation, an equation like 5x plus 2. 5x plus 2, we can say that 5 is standing for a, x is the single unknown we're talking about, and 2 is constant. So x is the single unknown, then we got 2 to be equals to 12. So we got ax plus b equals to c. In this case, the unknown is x, and we are supposed to find the value of x in this regard. So as we have been doing, we have to first group like terms. Group like terms means the terms of the same kinds are being put together. I've said time in, time out that the term 5x is not a number, but it's telling you that the variable x is occurring 5 times. But this is a number 2 and this is a number 12. So we are going to get 5x here equals to 12 minus 2. Then, because they are numbers, we just subtract 2 from 12 and we are going to get 10. So I'm having 5x here equals to 10. Now I want the value x, I want the base, so that is the value x. So to be able to get s, I have to let 5 cross the equal sign. So I divide here by 5 and I divide here by 5. So 5 crosses, then x here equals to 5 goes here 2. So x now becomes 2. For you to be sure what you've done is correct, is multiplication factor. So this one is 2. 2 times 5 is gonna give you 10, plus 2 will give you 12. This will make the linear equation correct. Okay, so to solve 6x minus 20, 4x minus 8 in both sides of the equation. So solution. What I have to do is first group like terms. So grouping like terms, I'm going to get, I'll first work it again. 6x minus 20 equals to 4x minus 8. So when I'm grouping like terms, let terms of the same kind go to one side. I'm going to have 6x. Then 4x is smaller, so it will cross the equal sign. Over here it is positive. When it cross the equal sign, it becomes negative. So I'm going to get minus 4x, then minus 8. Then negative 20 will cross the equal sign and become positive 20. Okay, so when I take 4x from 6x, I'll be left with 2x. Then minus 8 plus 20. You are owing 8, you have 20. So if you pay off your 8, you'll be left with 12. Okay, so what you do is you divide through by 2. Now we have x here to be equals to, this goes here 6. So x equals 6. So you can prove to both sides of the equation must be true. Now, to check to see what you have done is correct. If you got x is 6, x is 6, let's see, 6 times this is 36. 36 minus 20 will give me 16. Okay, now 6 times 6, 4 times 6 will give me 24. 24 minus 8 will give me 16. So the left side of the equation is equal to the right side of the equation. That means at the end of the day, whatever is found here must be equal to what is found here. Okay, so equation containing brackets. Now these are what we're supposed to do. If the equation contains brackets, we first expand the bracket, we group like terms, and we solve for the unknown. Let's see example. Good. Now we have the equation which says if m in a bracket, if 4 into bracket m plus 4 equals to 18, find the value of m. So how are we going to get m? First, we've known there are 2 ways. We can just divide through straight and later subtract, but what we can do to make it more simpler, since let's see, we write a question, m plus 4 equals to 18. Good. What I'm saying is that assuming this 18 is a multiple of 4, I would have first divided by 4. Then I now let this 4 cross. But because this 18 is not divisible by 4, it's not divisible by 4, I only have to expand the bracket. So 4 times m will give me 4m. Then 4 times 4 will give me 16 to be equals to 18. So I group like terms. So I've got 4m equals to 18 minus 16. So 4m equals to 2. I divide through by 4. 4 here and 4 there. Okay, so 4 cancels 4. M here, 2 goes with self, 1 goes to 4, 2. So m is equals to 1 on 2. That is the value of m. So let's solve this. So solution. Let's follow the law. We'll first open the bracket. So before we do that, let's rewrite the question. So 4 n minus 3 n plus 2 equals to 2. So 4 times n will give me 4n. Then 4 times negative 3 will give me minus 12. Okay. Negative 2 times n will give me like 2n. Negative 2 times 2 will give me negative 4. This one equals to 2. Okay. Now there are some terms which are common. So we are going to group like terms now before we go further. So I've got 4n. I've got 4n here minus 2n. That means 4n, 2n have been brought close. Good. Then minus 12 minus 4 equals to 2. Now 4n minus 2n will give me 2n, meaning that I have 4, I'm subtracting 2. And I owe somebody 12. I owe another person 4. So I owe how many? 16. 12 minus 16 and minus 4 is equal to 16 equals to 2. So I want to find n, so I have to let the 16 cross the equal sign. That is, we group like terms. So grouping like terms, so I've got 2n equals to 2 plus 16. So 2n equals to 18. Okay, divide both sides by 2. So n equals to 9. So n equals to 9. Good. Said equation containing fractions. If the linear equation contain fractions, the linear equation contains fraction and are separated by equal to, that is this sign, apply cross multiplication. Let us look at some of the examples in the YPC setup. So we have got these 3 questions. The first one says, if 3 on 15 is equivalent to 45 on A, find A. If 9 on 21 is equivalent to 1 plus x on 7, find the value of x. Then if 1 on x equals to 1 whole number, 1 on 2, find the value of x. Let us take it one by one. So solution. Now the term equivalency sign. The equivalency sign is the same as equals to, or this is equivalent. That's the equivalency sign, and it is the same as what? Equal to sign. So when you hear equivalent, it means that it is equals to. So you can either use the sign or the sign, and both means the same. So when it comes to I, it is going to be 3 on 15 to be equals to, that is the equivalency, 45 on A. Good. Now what I say is, I've been told in this regard I have to apply cross multiplication. But do I have to do it straight away? Whilst I know that this 3 can go into 15. So in this case, I have to reduce it so that the figures will not be too huge. Now 3 will go to itself 1. 3 will go to itself 1 and go CF 5. I will not tamper with this. So I've got 1 over 5 is equals to 45 on A. So what is going to be the value of A? We say anytime there's equal to between two fractions, you apply cross multiplication. At first I divide it so that I don't let the figure I'm going to continue dividing. So A will multiply 1, so this one will go to having A times 1 will give me A, then 5 times 45. 5 times 40 is 200. 5 times 5 is 25. So I'm going to get 225. We call it speed mass. Let's say 8 multiplies, let me do it this way. 8 times 1 equals to 5 times 45. 5 times 45. Now, it may give us problem, but we know it's 45 is of two numbers. So I'll use the speed mass. So A here must be equals to, into bracket, 5 times 40, or 5 times 4 plus 5 times 5. So A now is equals to 5 times 40 is 200 plus 25. So A now is equals to 225. 225. So that is the final value. That is the final value for it. Let me bring it a little bit backwards so that it can be more seen. So we get our A to be 220. Now one may ask, how did I come by this? Now you can see the 45, I splitted it into two. Let me use black ink here. I splitted them into two. So this is 40 plus 5. And with each aspect is being multiplied by 5. So to speed my mass, I only split this 45 into tens and ones, and then 5 will multiply them. I call it speed mass. So if you use that approach, it rather makes figures whose multiplication become a bit difficult to become somehow simple when during the time of examination. So we try to use this. Let us look at the other questions. Okay, so we have the second question, which is 9 on 21 equals to 1 plus x also on 7. So how do this one goes? We need a space. Now always, as you are solving, check to see the first fraction given. Are they multiples? Are they factors? Is there a number that can go into them? Now you check to see a number can go into 9 and 21. The number 3 can goes to 9 3, and 3 goes to 21 7. So this whole fraction can be rewritten as, let me use the arrow. So this whole fraction can be rewritten as 3, marker is weak, 3 on 7 to be equals to 1 plus x on 7. So what next? Now do you know that we are supposed to apply cross multiplication? That is whenever there is equal to between two fractions. But there is 7 here. Do I have to let this one go, let this one expand, and for it become so difficult? We want to simplify it. So once there is 7 here, this one only multiply the numerator and the 7 will cancel. So in this case, instead of multiplying, I'm just going to get 3 times 7. That is applying the cross multiplication divided by 7 to be equals to 1 plus x. So this 7 will cancel the 7. So when that happens, I'm having 3 to be equals to 1 plus x. Then I'll let 1 cross the equal sign. So I'm going to get 3 minus 2 equals to x. Therefore, x equals to 3 minus 1 equals to x. Therefore, x equals to 2. So x in this regard equals to 2. Okay. Let me limit my handwriting. I'm further explaining it again. So as we cancel out, we got 3 over 7 and 1 plus x over 7. The best thing to do is that we have to apply cross multiplication. This 7 will go and multiply 1 and x, and 7 will also go and multiply this, but the figure at the denominator here is 7, so we don't need to just let it go and later redefine it. We can just work it straight because speed is very critical. So what we are going to do is that we are going to let this one multiply. So I'm going to get 3 times 7 still divided by 7. I will not let the 7 go, to be equals to 1 plus x. Know that every number is divided by 1. So once this one is a fraction, this one is also divided by 1. So in this case, 7 cancels 7. I'm left with 3 to be equals to 1 plus x. What I want is x, not 1 plus x. So I'll let 1 cross the equal sign. So I'm going to get 3 minus 1 is equals to x. Therefore, x is equals to 2. So the value of x in this regard is 2. So if x is 2, then you can check. You see here gives me 3 over 7. So if this one is 2, 2 plus 1 is 3 over 7. So both sides of the equation is correct or are correct. Good. So we got 1 over x, one whole number, 1 over 2. To be able to work it, you have to change this figure to what you call improper fraction instead of the mixed number. So my next line is 1 over x to be equals to 2 will multiply 1, then you add 1 to it. So I'm going to get what? 3 over 2. Okay. What I want is x. So with this, I'm just going here. Good. I'll just apply cross multiplication because the figure I want here, the variable I'm looking for is a denominator here. So because the variable is a denominator here, I need to apply the cross multiplication. So 2 will multiply 1 for me to get 2. Then x will multiply 3. I'm going to get what? 3x. So I want x, not 3x. So I divide here by 3 and I divide here by 3. So 3 cancels 3, x equals to 2 on 3. So x equals 2 on 3. This is the first part of the fraction. Okay, so linear equations containing fractions. This is the second part. The first part was when the two fractions and there's fraction in between them. That is when you manipulate before you apply the cross multiplication if necessary. But this one we said linear equation containing fractions. If the equation contains more than 2 fractions and in one side of the equation the fractions are separated by addition or subtraction, make sure all the fractions have common denominator before you group like terms. So this one is very, very important. So you have to just manipulate the fractions and see them having equal denominator before you do your manipulation. Let's try some examples. So let's see how we solve these questions. Solution. The first one, we says that 1 over, what is I? 1 over x plus 1 over 3 equals to 1. Know that 1 is also over 1 because every number is divided by 1 and any number divided by 1 is the same number. Good. So what am I going to do with this? I just have to make this one a single fraction. So I'll write the LH, that is the left hand side, as single fraction. As a single fraction. And how am I going to let it be a single fraction before I apply my cross multiplication? What I just do is this. I have to make sure both of them are having common denominator. So to have common denominator, look at 3. I'll multiply 3 by the numerator and the denominator of this fraction. So 3, 1, 3. 3 times x is 3x plus the same way as I multiply the denominator here by the numerator and the denominator. Likewise, I will multiply the numerator and the denominator here by also s. So x times 1 will give me x, and x times 3 will give me 3x equals to 1 over 1. Now the denominators are the same, so it means we can add. So in addition, what we are going to have is we're going to get 3 plus x all over 3x. Once the denominator are the same, you can take the common denominator. So this is 1 over 1. At this point, what we do is that we can now apply our cross multiplication, because this is a single fraction and this is another single fraction. So 1 will go here and this will go there. So I'm going to get, let me bring it here so that it will be more open. I'm going to get 3 plus x to be equals to 3x, group like terms. So 3 equals to 3x minus x. 3 equals to, taking s from 3x will give me 2x. Divide here by 2, divide here by 2. Now you can't do anything about it, so x in this regard equals to 3 over 2. So that one becomes the solution for x. Okay, so we look at this question also. Yesterday I explained to you that anytime you've got such a relation, the numerator will multiply the figure, which is the variable. So anytime you have got a figure in front of a variable, the variable multiplies the numerator and the denominator continues dividing. So we are going to get y over 3 plus y over 5 to be equals to 8 over 1. As we did, we have to make sure that we write this as a single fraction. And how are we going to do that? Now we take this, we multiply it by the numerator and the denominator. So 5 times y will give me 5y. Then 5 times 3 will give me 15. Plus 3 will multiply y. I'm going to get 3y. 3 by 15 will give me, 3 by 5 will give me 15. To be equals to 8 over 1. Any number divided by 1 is that same number. So going further, I write this as a single fraction. Because the denominators are the same, then 5y plus 3y divided by 15 must be equals to 8 over 1. This is how it is. Then what next? Apply the cross multiplication. So to apply cross multiplication, 5y plus 3y is going to give me 8y over 15 to be equals to 8 over 1. Now 1 will multiply here and 15 will go here. So I have 8y to be equals to 8 times 15. Good. I need y. In this case, I have to be fast. I don't need to multiply 8 by 15 because there's 8 here. So somebody will say divide through by 8. I need y, so I divide here by 8 and divide here by 8. So 8 will cancel 8. Y here equals to, so it has cancelled this 8, so I'll be left with y 15. So y here equals to 15. So if y is 15, then 15 divided by 3 will give me 5. 15, if y is 15, 1/3 of 15 will give me 5. Then 1/5 of 15 will give me 3. So 3 plus 5 and 5 plus 3 will give me 8. So the equation is correct at this instance. Okay, let us try this. Examples 2. Unlike the one we did earlier, this one contains brackets and fractions. So we look at 1, which is 2 on 3 x minus 3 equals to 5 on 6 x plus 6. So how are we going to work out this? We said this part is equals to that. If it is objective, you can just manipulate and just guess and put a value for x and see whether it will work. But if it is theory, how are you going to do it? First, make sure that it has become linear. So look at the figure over here. The highest denominator, always look out for the highest denominator. So the highest denominator is 6. So you'll find a number that this one will be multiplied with, so that you clear away the denominator. You have to let it become linear. So because the highest denominator here is 6, we say you multiply through by 6. Multiply through by 6. So I'll multiply here 6 times 2 over 3 x minus 3 to be equals to 6. 5 on 6 s plus 6. So 3 will go to 6, 2. So 2 times 2 give me 4 x minus 3. Then 6 will cancel 6, 1. So I have 5 x plus 6. I'll open bracket and group like terms. 5 times x will 4 times x will give me 4x minus 12. 5x plus 30. Okay, good. I have to group like terms. The x aspect here is higher. So when you are grouping like terms, it is advisable you group it at the point where the x is bigger. So I'll rather bring 4x here and bring 30 here. So I'll have minus 12 minus 30 is equals to minus 12. Look, I group the like terms from here. This 4x and 5s. 5s is bigger than 4x. So in that case, I'll send 4x. I'm going to send 4s here and bring the 30 here. So I've got minus 12. Then when 30 crosses, it becomes negative 30. So I've got 5x minus 4x. Okay, so minus 12 minus 30 will give me minus, let me send everything here. So I've got minus 42 to be equals to x. Therefore, x equals to minus 42. X in that regard equals to minus 42. Good. So we have got x plus 2 divided by 3 plus 2x equals to 10. So once this is fraction, bear in mind that these two are also fraction. So what you do now is you try to make it linear. How are you going to get rid of this denominator? So to get rid of this denominator, it means that when you multiply through the equation by the denominator here, so multiply through by 3. So I have 3 times x plus 2 all over 3 plus 3 times 2x over 1 is that same number. Then 3 times 10. So in that case, 3 will cancel 3. I'm left with x plus 2 plus 2 times 3x will give me 6x equals to 30. Okay, it's a matter of grouping like things, and let's see how it goes. I've got x plus 6x equals to 30 minus 2. X plus 6x will give me 7. S equals to 28. Okay, so I divide here by 7 and divide here by 7. So what do I get? X times what number will give me 28? Okay, x times 4. So 7, 7. When x is 4 times 7 will be equals to 28. So I just get my x to be equals to 4. Good. Our next on the line is the application, how we model equation in the solving of the linear equations. We also have to look at linear equations of two unknowns. So once we've done single unknown, we'll be doing two unknowns. Then we'll apply both or on the applications. So until we meet again, thank you.